So let's go through the use case of selecting 4 wells, and in each of those wells we want a 4x4 tile, and for each of those tiles or each of those fields of view we would like to set a Z-stack. So first we're going to set or select the wells that we're interested in. So in this case we can see here I am in row F and I want to select wells F2 through G4. So to select those wells I go to the well selector, hold down left click here, and select those 4 wells. So now we have, without further modification, we're going to take a single field of view in each of these wells. In order to take multiple fields of view, we're going to change our scan size here. So we've chosen a scan shape of a square, but we're going to change our scan size to accomplish that 4x4 grid. So now we have a 4x4 grid that has a 10% overlap so that we can achieve good stitching. We also mentioned that we want to add a Z function to this as well, or we're going to add some depth, so I've selected Z. I'm also going to use the from bottom, so I have from bottom and I have set range. I'm going to use from bottom so that I can employ laser-based autofocus to maintain autofocus as we travel across the sample. So the Z focus parameters that I've chosen here are a number of Z slices of 10, and a distance between those slices of 1/2 micron or so. I'm actually going to increase this to say 60. So now we're going to take a total volume of 30 microns, so 60 slices, 1/2 micron each is 30 microns. And now I'd actually be ready to acquire this acquisition if I was happy or if I was assured that I can maintain focus across these different fields of view. Let's say I'm not super happy or not super confident though that I'm going to be able to do that, and I'd like to employ laser autofocus. So to employ laser autofocus, we first have to make sure that it's initialized. So if I go to the laser autofocus tab, I can see that it's initialized because I have the option of setting a reference. When the laser autofocus has not been initiated, you won't be able to set a reference, in which case you'll have to go to the laser-based autofocus settings and go ahead and run through the initialization routine, which is laid out. How to do that is laid out in another video. Okay, but we are able to set the reference, and an important point here is that when you use laser autofocus, wherever you set that reference is going to be the bottom of the stack, bottom of the Z stack. So we don't necessarily want to set it within the focal plane. We actually want to set it below the focal plane of interest. So in order to do that, we would want to go then to stages, or I'd say in order to do that in a robust fashion, we want to go to stages and move the Z drive down by a specific amount. So in this case, I'm going to move the Z drive down by about 15 microns. Okay, so we're slightly below focus, and I'm actually going to set that as a reference. So now the behavior that we'll see when we collect these Z stacks is it's going to visit each of these fields of view. It's going to, again, center on the XY. It's going to then employ the laser autofocus to find the Z. The Z is going to be the bottom of the Z stack that we take. And then it's going to go through and take images starting at that bottom Z and collect 60 Z slices at a Z step size of 1/2 micron. So when I go ahead and start this acquisition, I'm going to expect it to collect each of these fields of view, and we should watch it actually go below focus, collect the entire Z stack, and then go to the next field of view.